Hello, this is Derek, and this section is going to be about signed numbers. In the notes, I have out these kind of formalish sounding rules for adding and subtracting signed numbers. I think I'm just going to talk through it in sort of the way that I present it. But here's a little bit more formal version if you're a person who really likes some steps. Let me remind you in terms of products and quotients on signed numbers. Remember, if we have if you are multiplying or dividing two numbers with the same sign, they're going to come out positive. So positive and positive makes positive, negative and negative makes positive. And if you have mixed signs, that's going to come out negative. And then the other one is quotients involving zero. So if you go 0 divided by a number, so 0 divided by 7, if I have nothing, I divide it among 7 of us, we still have nothing. But if I try to divide 7 among 0, that makes no sense, and then that gets you undefined. For the computer, what you would put in this case, and you'll see this as we go on through the quarter, is DNE. That stands for does not exist. And so that's a little computer shorthand for undefined or things that don't have solutions. Okay, so let me do some examples, and I think me just showing you how I think about it makes probably more sense than those rules, but there they are in the notes if you want to check them out. So when I'm doing signed numbers, I just pretend like it's money. If I have 15 bucks and I spent 11, I still got $4. So, okay, that one's pretty clear because it's just regular math we do all the time. So for this one, again, they had those kind of formal rules back in the notes, but I just think of this as I spent $15 and I spent another $11. So if you think of spending 15 and then another 11, that would be $26. But if you think of it as like spending, then that's going to be negative, right? Because it's money that is leaving you, not money you're taking in. So you spend 15, spend 11, and now you're $26 in the hole, or you spent 26, negative 26. For this next one, I think, okay, I spent 15, I have 11, so how much am I still in the hole? How much do I got to come up with? So I was down 15, I climbed back up 11, so I would still be at minus 4, right? If I think of going negative 15 units this way and then back 11, that leaves me 4 to cover. When we're doing subtraction like this with these double negatives, easiest thing to do with that is minus a minus is plus. And the reason this is if you think of what is the opposite of negative 11, well, it's positive 11, right? So I can rewrite this as 15 plus 11, and all of a sudden then that looks super easy, and it's just 26. Likewise here, instead of minus 15 minus a negative 11, which is like the most obnoxious way to say that ever, this is minus 15 minus negative makes plus 11. So it's really the same thing as this problem. I'm down 15, I climb back up 11, but I'm still 4 in the hole. So that's kind of more how I think of adding and subtracting with signed numbers, is I just think of it as money, and I rewrite my subtraction as addition. So then we got some multiplying and dividing. And so this is going to be a positive and a negative. So that automatically means if I've got mixed signs like that, my result's going to be negative. And I could multiply straight across, right? I could go 2 times 1. And that will be, let me say a word on this negative sign right here. Let me pop down here and say it. So if I have, I'll just make a fraction, negative 2/3. I can say I have negative 2 over 3. I can say I have the negative of 2/3, or I can say I have 2 divided by negative 3, and all of those things, if this is negative 1, and I cut this into thirds, all of those points are right there on the number line. They're all at that negative 2/3 spot, 2/3 of the way to negative 1. So it doesn't matter if the numerator, if the sign is in the numerator, kind of right in front of the fraction, or the denominator. Those are all indicating that same place. Okay, so that said, you'll see these signs kind of pop around a bit, so don't be alarmed by that. It's just saying that it's a negative number. So here I could go 2 times 1 and go, we'll make that negative in the numerator there, and then 5 times 4 and get 20. But then you just have to be careful to make sure you reduce your fraction, and so you get negative 1/10 there. But we could also reduce before we multiply, which is what we saw in that little review section. So I could also say 2 goes into 2 once, 2 goes into 4 twice, and now 1 times negative 1, that's negative 1. 5 times 2, that's 10. So same thing, it's just whether or not we multiply straight across, reduce after, or if we can see that reduce during the problem, that's actually usually easier. B on this is 11 divided by 0, so I can't divide by 0, so that would be a DNE. Another way of thinking of that, and sometimes you'll get just a little hung up on this, think about if I have 6 divided by 2, right? That would make 3. And that's because 2 times 3 makes 6. If I have 0 divided by 11, that one does make 0 because 11 times 0 is 0. But if I have 11 over 0, there's nothing I can put here that 0 times that gets me back to 11. So that's why we cannot divide by 0, and that's going to be our D and E. Part C down here is just 3 times 4 times 1, right? That's just 12. And then we have 1, 2, 3 negative signs. So anytime there's an odd number of negative signs, it's going to be negative. If it's an even number of negative signs, then they would all pair off and become positives. And then this one, so it's a division, so we'll rewrite that as a multiply. So let's call this negative 4/3 times 6 over 1 negative. And if I wanted to write this a little simpler, I could, because it's a negative to divide by a negative, I could actually just drop those signs and write it that way. Since I know the answer is going to be positive, I could write it as an equivalent. 24 over 3 would be 8, or I could also do a little reduction there, and 4 times 2, so then that still would be 8. Okay, number 3, we have use order of operations to simplify. So here we got to be a little bit careful as to what's the operation we're doing. When we see these parentheses, that's going to be a multiply in there. Likewise, that 4 is right up against that parenthesis, so that's a multiply. So we have 2 multiplies, and then whatever the sign of this is, that's going to be the operator for the next line. Let me show you what I mean by that. So here we got negative 3 times negative 5. That's going to make a positive 15. I don't need the positive there because there's nothing happening before it, so it's just implied positive. But here, when I go negative 4 times negative 10, that makes 40, right? But now I got this kind of floating 40, so it's a positive 40, and that's what I mean by that. Whatever the sign is, that's going to be telling me what to do with the operator for the next line. So if this had been a plus, this would be a minus, and then it would be telling me I needed to subtract, had that come up negative. And then just 15 and 44, 55. Over here, so we'll do our numerator and our denominator, and then we'll put those together at the end. So we got 5. Negative 6 times negative 2 is positive 12, so that's going to be adding 12, even though that started off as a subtraction. And here we got negative 4, positive 5 times negative 3, so that one looks like it's going to be an addition, right? But then that sign, it's like plus and negative, so you might as well just write it as minus 15 because it looks easier. And then 5 and 12 is going to give us a 17 in the numerator. And then negative 4 minus 15, so we're down 4. And then we're going in the hole another 15, so that's going to be a negative 19. A note on these fractions. So we don't love a negative sign in the denominator. It's not quite simplified. So usually you'll see it in the numerator or possibly written right in front. When you're typing in your computer, just do that and that will work fine. It should take this, but it's just not quite. We prefer that sign up here. So I would enter them in that way. Number 4, so this is just doing the those inverse operations that we saw a couple of sections ago, but now with sign numbers. So negative 12x equals 15. So remember for for multiplication and division, those two are their inverse, so those are going to undo each other. When we multiply and divide, when we start using sign numbers, we want to use numbers with the same sign. And the reason for that, hopefully you can see it in this example, when I go negative, if I had just gone 12, I would have negative 12 over 12, and I would have a negative x. And I'm really trying to solve for positive x, not negative x. And so that's why I want to use this negative 12. So the negative 12 over negative 12, that makes 1x or positive x. And then 15 over 12 with a negative sign. And that reduces a little bit, so remember we go 5 times 3 and 4 times 3. And then reducing, we should get negative 5/4 there. Here, so this time we have k minus 10 equals negative 3. So this one is a subtraction, so we're still going to undo that with division. And the reason we're not doing anything different with the sign there is this we're trying to come up to 0. We want this to be k plus or minus nothing. So we want this to be 0, so we're using opposite signs. Here we wanted this one to be a 1x, so that's why I use the same sign so that it comes out positive instead of negative. So that's kind of the only difference in this section from that last one. So we'll add our 10 to both sides over here, and that gets me K. Those are gone, down 3, up 10, so I would have $7 if that was money. This one, let me write this down here so you can see a little better. So this has a division and it's negative. So my goal is to make this come out to positive V. So I'm going to multiply both sides by -9, because -9 or negative times negative will make positive and the 9's cancel. And of course what I do on this side I have to balance out on this side. And then 9's drop out and negative gives me a positive V and -27. And then here, so we'll go, this is 12 minus H equals 5. I could add the H over and subtract the 5, or I could also subtract the 12, either way. I'm going to subtract the 12, so I can show you what to do when you get that negative right there. So this is negative H is what's left. And careful not to lose that sign. 5 minus 12 is going to be, so I have 5, I spent 12, and so I am 7 in the hole. I don't want to know what negative H is, I want to know what positive H is. So you don't have to show this step, but what I'm doing is multiplying, or you can think of it as dividing, either one would work fine, both sides by -1. So then negative and negative makes positive H, negative and negative makes positive 7. And certainly you could just look at that and say negative H is -7, so then positive H must be positive 7. But that's why that works. And then last one, same idea just with some words. The temperature at noon was 2 degrees Celsius and dropped 15 degrees Celsius over the next 12 hours. What was the temperature at midnight? So write an expression using negative numbers to model a situation. Okay, so it was 2 degrees and then it's going to drop 15. So that's basically the expression. And then simplify your expression. Okay, so 2 minus 15, that makes it -13. And then saying the temperature at midnight was, yeah, if it started off at 2 and dropped 15, that's super hella cold. Then at midnight, it's going to be -13 degrees Celsius.